20 marks. That is what at stake in 2013 and 2012 UPSC CSE Mains question on transmission line. Today we are going to solve 2013 problem on length in wavelength and phase constant, along with 2012 numerical on transmission loss and return loss. I'll show you the exact step-by-step calculation to ensure your answers are precise and exam ready. Let's dive into the first problem. A lossless transmission line with air dielectrics is 12 meter long. What is the line length in wavelength and what is the value of the phase constant at 15 megahertz? Let's dive into the solution. What are the things given here? We have length is equal to 12 meter and it is talking about dielectric, hence phase velocity will be Vc, which is 3 into 10 to the power 8. We need to calculate length in terms of length already given, but in terms of wavelength, that is lambda. This we need to calculate, and what is the value of the phase constant, that is beta, at 15 megahertz. Now we need length in terms of wavelength, right? So if you will be able to calculate wavelength, what is the formula to calculate? Lambda is equal to 2 pi by beta, right? And anyway beta we have to calculate, right? Now we need to calculate beta. Beta is equal to omega by beta. We know that Vp is equal to phase velocity is equal to omega by beta, right? So here, from here we can write beta is equal to nothing but omega by Vp. Omega, what is the value of omega? 2 pi f upon Vp, which is nothing, 3 into 10 to the power 8, right? This will be 2 pi f. We have 15 megahertz, 5 into 10 to the power megahertz 6 upon 3 into 10 to the power 8. This is 5 times, and this 6, this will be 10. This can be written as pi by 10. So beta we got, that is pi by 10. This is the first answer that we were looking for, right? Now we need to calculate lambda, so that we can put 12 in terms of lambda, right? What is the formula? We know that we have just calculated beta. We will do nothing, just substitute this particular value here, right? From this equation we can write that lambda is equal to 2 pi. What is the value of beta? We have just calculated pi by 10. We'll put 10 here. Lambda is equal to 20 meters, right? Now we want length in terms of length in terms of lambda, right? Now we can do that. Length is equal to 12, lambda is equal to 20, right? This we can write as 3 by 5. So L can be written as, what we have done here, we have make sure that L by lambda, what is the value of lambda? 12. We have taken basically the ratio of lambda, L and length and lambda. So what is the value of length? Length is given 12, lambda we have just calculated, we have substituted, this is 3 by 5. L can be written as 3 by 5 lambda. This is the answer that we were looking for. Let's see another 12 marker question. A lossless transmission line having a length of 100 meters is terminated by a resistive load of 200 ohms. It is fed by a generator of voltage 0 volts and has an impedance 100 ohms. If the characteristic impedance of the line is 300 ohms, calculate the transmission loss and return loss in decibel. What are the things given here? We have length, which is 100 meters, terminated by a resistive load. Resistive load, that is ZL 200. Its generator impedance, which is given as 100 ohms. And if the characteristic impedance, okay, now we have the information of Z0 also. This is ZJ. generator. Now this is also given as Z0 is also given as Z1. We have to calculate transmission loss and return loss in decibel. In dB they are asking for. Now see, we know all the formula that is related with reflection coefficient, right? So we will begin by solving the value of reflection coefficient. What is reflection coefficient? What is the formula? That is nothing but ZL minus Z0 upon ZL plus Z0. What is the value of ZL? 200. What is the value of Z0? 300. We will simply substitute this plus 300. That is minus 1 by 5. What is modulus of this? That is 1 by 5. That's the transmission. Sorry. That is transmission loss is nothing but whatever the attenuation loss. Obviously we are talking about in dB, but attenuation loss plus reflection loss. This is total loss. It is a lossless transmission line. We have, it's given in the question at first only. This is a transmission line. Then alpha is equal to 0. So from this we can say that whatever the transmission loss we are having, that is nothing but reflection loss, right? So now we need to calculate what is reflection loss, right? Reflection loss, what is the formula? That is nothing but 10 log. What is the formula? 10 log 1 upon 1 minus that is reflection coefficient at load, right? This is reflection coefficient at load. We have calculated reflection coefficient at load, right? This is the reflection. This is the formula. How we came to this formula, that I can define. We can directly substitute in this equation and we will get the answer, but I want to deviate little bit here, just trying to explain how we have arrived to this particular formula. So what is reflection loss? So reflection loss, right? What is it? It is basically define the ratio of, it basically measures the ratio of incident power to the transmitted power in decibel. It basically tells how much power was lost from the transmission perspective. That's it. Okay, now we will try to calculate power, incident power and transmitted power. That's what we will try to do. We know that incident power is equal to power loss plus power transmitted. So PT can be written as Pi minus PR. Right, I'll try to divide this by Pi. This is 1 minus PR by Pi. Right. Now, what is PR by Pi? PR is nothing but reflection coefficient square into Pi. So this was PT by Pi. Now Pi by PT is equal to 1 upon 1 minus gamma square. Reflection coefficient square. Now we know that reflection loss is equal to 10 log base 10 Pi by PT. We just substitute 10 log 1 upon 1 minus. That is nothing but this formula, right? Now just we will try to substitute the value. We have calculated what is the value. We have calculated is equal to 1. So this 10 log 1 upon 1 by, this is 1 by 5, that is 1 upon 25, right? that is 10 log 1 upon 25 minus 1 upon 25. This will be nothing but 10 log 24 by 25 by 24. The value of this we have calculated is 0.1773 dB. What we have calculated? Reflection. And from this equation we know that transmission loss is nothing but reflection loss when we are dealing with the lossless transmission lines. When lossless transmission line is there, this becomes attenuation loss becomes 0. So we can clearly write that transmission loss is equal to reflection loss, which is 0.1773 dB. Answer. Now the second part of this very question was written loss. The formula, okay, now second part of this we need to calculate written loss. What is the formula of written loss? That is nothing but minus 20 log of reflection coefficient, right? Minus 20 log 1 by 5. That is nothing but 1.398 dB. This is the second answer that we were. This is the second answer that we were. Hey, great to see you until this point. Please drop your doubt in the comment section if you have any. Please subscribe to the channel Sinc UPSC for such videos. There are plenty of videos coming up for other subjects too. Happy learning.